So this topic name is potentiometer. Now, what is a potentiometer? It's very important topic with respect to all your competitive exams. So what is a voltmeter? Now, an ideal, what is this ideal voltmeter? You have done voltmeter before in your previous classes as well, which does not change the potential difference. So let's go through the voltmeter concept once. You remember that voltmeter was something like this. If there is a resistance which is connected across the cell, then you connect a voltmeter in parallel. Remember, this was voltmeter always connected in parallel, and the ideal voltmeter must have infinite resistance, isn't it? It must have an infinite resistance, and the purpose of the infinite resistance was that you don't want any current to flow in the voltmeter. You don't wanted any current to flow through the voltmeter itself. You wanted all the current to flow through the resistance so that the potential drop across the resistance is measured effectively. If any current flows through the voltmeter, then the exact current through the resistance is not flowing, and your measurement of the voltage will also be imperfect. So that was the idea of a simple voltmeter. You have done this before in your junior class. But what is a potentiometer? Our topic is not voltmeter. Our topic is potentiometer. So why are we discussing voltmeter first? You see, an ideal voltmeter which does not change the potential difference needs to have an infinite resistance. Okay, it must have an infinite resistance, but a voltmeter cannot be designed to have an infinite resistance. Okay, infinite resistance is like something hypothetical. You'll have very high resistance, but still be a high resistance, mean it will a very small amount of current can still flow. Okay, infinite resistance was because you don't want any current to flow. So the potentiometer is one such device which does not draw any current from the circuit. That means potentiometer is a device which will not take any current. Voltmeter will take a current. Potentiometer will not take any current. Okay, so potentiometer does not draw any current from the circuit and still measures the potential difference. So potentiometer in a sense is acts like a ideal voltmeter. A potentiometer is a device which measures an unknown EMF or potential difference accurately. Okay, so potentiometer would become that device, an ideal voltmeter. It will not take any current from the circuit and yet it will measure the potential difference. Now, to understand the concept of potential difference, you must be clear about two different concepts. Okay, two different ideas you should be clear about. So first idea is that consider that you have a resistance, and this resistance is basically a wire. Okay, so this is a wire, okay, often some finite length L, and you have connected this across a cell. Okay, you have connected this across a cell, and the current flowing in the circuit, you can say V is equal to IR. Okay, the current is flowing in the circuit and the potential drop V is equal to IR, very simple. And this resistance is the resistance of this. Now R can be written as rho L by A. So V is equal to R I into rho L over A. I hope you remember what is rho L and A, resistivity, length over area. That means you see the potential drop is proportional to length. Potential drop is proportional to length. Now, what does that mean? Consider that the potential or this potential of the cell is let's say 200 volt. 200 volt is the potential of the cells. That means 200 volt is going to drop across this resistor. Let's say the length of this resistor happens to be 100 centimeter. Now, if the 100 centimeter is the length, so I want to know what is the potential drop for 50 centimeter. Or I want to know potential drop for 25 centimeter. That means all I have to find is something called potential gradient. Okay, I have to find potential gradient, and potential gradient will become that value V by L. Very simple. So here our potential gradient will become how much? V by L. Potential gradient V is 200 here. Okay, V is 200 volt, and the length was 100 centimeter. So our potential gradient will come to 2 volt per centimeter. That means that if I want to measure the potential drop between any 2 points, let's say this point here, this is 30 centimeter. Okay, from this length 30 centimeter, and then there's another point at 70 centimeter. Okay, another point at 70 centimeters. So I want to know what is the potential difference between these 2 points. So the length difference in the length is 40 centimeter, and I know 2 volt is potential drop is happening for every centimeter. That means 80 volt of potential drop. So this point and this point will have a potential difference of 80 volt. Very simple. Okay, so that is how you find a potential gradient for any given specific resistor. If a resistor is given, you can actually find a resistor is given and an EMF is given, you can find a potential drop. So potential gradient, potential drop per unit length. Potential drop per unit length of the potentiometer wire is known as potential gradient, and it is given by this expression K is equal to V by L. So you can have a volt per meter or volt per centimeter. The second concept that you have to understand is, let's say there is a resistance and you have connected this resistance across a cell, and let's say this cell is 10 volt. Now if you connect another cell here and make this cell as 5 volt, so what exactly will happen? That some current from this 10 volt cell is going to come here at this junction, and because you see the potential drop across this resistance, is 10 volt, because before this cell was attached, the resistance was consuming all the potential in the circuit. So the potential drop across the cell is 10 volt, and you have connected a cell of 5 volt. Okay, you have connected a cell of 5 volts. So what will happen, that some current will also flow in this circuit. Okay, apart from some current flowing through the resistor, some current is going to flow through this circuit. But if you do the same case with another resistor, but this time if you install a 10 volt cell here and also a 10 volt cell here, then you will see that the potential drop across this resistor is how much? 10 volt. And this is also 10 volt. That means no current is going to flow. The current from here will come to this junction, but the current will flow towards the resistor and back to the cell, and no current is going to flow towards this line. In this line, no current is going to flow. Okay, so what we understand, a very basic idea, that if there is a potential drop across the resistor, and you install and you put another cell parallel to that resistor, and then if you expect the current to flow into that cell or current not to flow into that cell, how to decide that? The potential drop across this resistor, first you have to measure that. If the potential drop across the resistor is more than the cell that you have installed in the circuit, then the current is going to flow. And if it is not so, let's in the second case where this cell has a 10 volt potential and the potential drop across the resistor is also 10 volt, in that case no current is going to flow. Okay, no current is going to flow. So that is the second concept you need to understand. If you have a doubt, please go back to the video, you see the same thing again. Okay, you need to get this clear, that potential drop across this resistance, if across this resistance, if this cell has a lower potential than the potential drop across this resistance, then the current is going to flow. And if this cell has the same potential drop across this resistance, then the current is not going to flow. If this cell has more potential drop across this resistance, for example, let's say the third case where this resistance potential drop is 10 volt and you installed a 20 volt cell parallel to this resistance, in that case what is going to happen is that the current, this cell will then become the driving cell or discharging cell of the circuit, and then again the current will flow, but the current is going to flow in the reverse direction. Now, and this cell current is going to flow like this will become a charging cell, this will become a discharging cell. So bottom line, if the idea is that if you don't want any current in this circuit, if you don't want any current in this cell, the cell, the one that you have installed on the top, if you don't want any current to flow in this cell, that means the potential drop, this potential drop must be is equal to the EMF of the cell. That must be is equal to the EMF of the cell. You install one ammeter here. You can install an ammeter and check out whether the current is flowing or not. Okay. So I want the ammeter reading to be 0. I want the ammeter reading to be 0. So this is what I will do. So that's the two different concepts that potentiometer, the basic idea depends on. Now, for some reason, potentiometer diagram in most of the books that is available in the market is very scary. The diagram of the potentiometer is pretty scary. It's scary in the sense it will have long wires, long this whole this long wire kind of thing. Okay, this kind of thing. So in the book that I'm using is have the same thing. If you check out the other books also, they will have this kind of diagram, and because NCERT itself has given this diagram. Okay, so but you don't need to think so much, because this is very hard to visualize. So you only have to visualize a part of this diagram. This diagram is a bit complex only because they have used this length of the wire as 100 centimeter, then again 100 centimeter, then again 100 centimeter, and so on. They have done it with 400 centimeter and so on. So you don't need to do this, and you don't need to draw this big diagram also. So you can actually do this whole thing without this diagram. And how? So first what you have to do is to draw one meter bridge. Now meter bridge, don't think it is a kind of a bridge or something. It is simply 1 meter long scale. Okay, it is simply a 1 meter long scale. If you go to your practical experiment physics lab, you will find such meter bridge kind of thing. 1 meter long scale is there. This particular 1 meter long scale will have a wire, a thin wire at the two end, connecting the two end, and this wire has the uniform resistivity. Okay, so resistivity is uniform, and the thickness is uniform, everything nice. Wire, not the non-uniform thickness is not there, and the resistance is proportional to the length and all this. So this is your meter bridge. What is this meter bridge? Now meter bridge is used for a multiple experiments. Few of the experiments you will do in your second PU class 12 syllabus, CBSE also has it. You will find it in your physics lab, and there are few experiments that you'll do on the meter bridge itself. Meter bridge can be used for variety of different electrical experiments. We are going to use this meter bridge to construct our potentiometer, because we are doing the potentiometer topic. So we will be using meter bridge for potentiometer. Now how to use the meter bridge to make a potentiometer? So you have this meter bridge. What you do is connect a cell across this meter bridge. Okay. So you connect a cell across this meter bridge, and you can have any cell here. Okay. This you can have any cell. This cell is not very much important for us. All that you want is to this cell to send some current. I mean, that's just flow some current in the circuit and all. So this cell is not very important for us. This cell will give out some current in the circuit. Okay. Very simple. Then from this end you connect another cell. Okay, you connect another cell, and you don't know the EMF of the cell. So let's say this cell happens to be an unknown EMF cell. Okay, just hold on. So this cell is unknown. Okay, this cell is unknown. We don't know the unknown EMF. So we don't know the EMF of the cell. We just want to calculate it. Okay. Now then you connect the cell to an ammeter. Okay, you have this cell, and then you connect the cell to an ammeter. So ammeter is there, and then you connect the cell to something called a jockey. So jockey is simply a pointing device, a pointed device, which you can make this device touch the specific point if you want. So you can connect the jockey here, connect the jockey here. Okay, connect the jockey anywhere you want to, if you want to connect the jockey here and so on. Okay, so this is what your potentiometer, the practical potentiometer. This is what you need. Go to the lab. This is what will be given by your lab assistant. The whole of this setup will be there. Now this whole setup can be used to do two things. Okay, there are two different things that you can do. Use this setup to find, that we'll discuss in the next video. If you have any doubt with the potentiometer, again go back to these two concepts. These two concepts are very important. That the potential gradient, the drop of the potential per unit length, this is very important. And the second one being this particular idea of how, when the current becomes zero. Okay, when does the current in this line become zero, and when it will not become zero. How the potential drop across the resistance must be is equal to the EMF of the cell that you have installed on the top, and so on and so forth. So if you have understood these two concepts, then move on to the next video.